Okay, guys, here we go with chapter 35, Alligations. Excuse me. In this one, we're going to learn how to set up an alligation and basically use alligations to determine how to prepare a concentration of an ingredient from two concentrations of the same ingredient when the desired concentration is in between the two available ones. So for example, if you need a 40 but you have a 90 and a 5, what do you have to do to get a 40% concentration? So that's pretty much what this whole chapter is all about. And I did a couple problems and they came out pretty nice and easy. So let me just tell you what I did. Let's start with the introduction. If a certain percentage strength solution is needed but not available, a technician can prepare it by mixing together a stronger percentage strength solution and a weaker percentage strength solution in appropriate proportions to achieve the desired strength. All concentrations must be in a percentage form and in the strength of the desired solution. And the strength of the desired solution must lie in between the stronger and the weaker solution available. If the concentration is not expressed in percentage form, then you need to convert it into percentage form. And for example, a solution is expressed as 1 in 200 parts, must be converted to a percentage. And again, in other chapters, we learned that if something that looks like this, it basically means to do 1 divided by 200, multiply it by 100, and you get a percentage. So you divide by the parts by the given part or whatever, and then you multiply it by 100 to get a percentage. Okay? These type of calculations are known as alligations, and they're set up using a similar tic-tac-toe board. So what are the rules to do this? Okay, so you set up your tic-tac-toe board. Okay, so your higher percentage strength goes here, okay, top corner, and then your lower percentage strength goes in the bottom corner. Whatever you are expecting to get out of the two goes in the middle, and then you subtract. You subtract the higher from what's required to get the number of parts for the lower, and then you get the lower and subtract it by what's required to get the number of parts for the higher. Okay, in this this form, there's no negative numbers. So if you are, for example, if you have a 0 strength and then you want a 1 strength, you don't put a negative, like you don't do 0 minus 1, for example, to get a negative. You just do 0 minus 1 or 1 minus 0 equals 1. Okay, just so you have that idea. There's no negative numbers here. So even if it turns out to be a negative, it's the positive of that number. And we'll see some of what I'm talking about in the examples. Okay, so the rules: the higher percent strength is always placed on the upper left box. The lower percent strength is always placed in the lower left box. The required strength is always placed in the center. The higher strength minus the required strength equals the lower strength. The required strength minus the lower strength equals the higher strength solution needed. Okay, at the end of the day, you're going to calculate how many parts are in total, and you're going to sum that up, and then you're going to do your problems as needed, as we're going to describe now. The volume of the higher percent strength solution needed is determined by dividing the number of parts of the higher percent strength solution by the total parts and then multiplying by the final volume. So for example, we have one here that says 60 minus 40 is 20. 25 minus 40, where this would have been a negative number, it's not. Okay, it's regularly 15, so you just do 40 minus 25 to get the 15. Okay, the total parts here would be 15 plus 20, which would give you 35. Okay, and then you divide the parts of the higher, so the 15 over 35, and multiply it by what's needed in order to get how much of that percentage solution you need. Okay, I'm gonna get into the examples just so we can start. Okay, let me get my papers in order. All right, so number one states, let me see if we could get this better. Does it look better like that? Maybe, maybe not. Okay. Oof. Okay. So number one states, calculate how many ml of 50% dextrose solution and how many ml of water is needed to prepare 4.5 liters of a 1% solution. All right. So we have our two percentages. Okay. We have a 50% dextrose, which we put on the top. And then we have water, which is considered neutral. So water and anything that doesn't have a percentage is considered neutral and 0. Okay? So you have your 50 and you have your 0 in your tic-tac-toe. Then you want to end up with 4.5 liters of a 1% solution. So then you stick your 1% in the middle because that's what your ultimate goal is. Okay? You want to mix these two pieces. You have a solution or a juice that's 50% strong, and then you have water, which is considered 0, and it's neutral. Okay, so 50 minus 1 is 49, and 0 minus 1 is 1 because there's no negatives. Okay, so what do you get? 49 and 1 gives you 50 parts. So in total, you're going to need to complete 50 parts of this problem. Okay, so out of this 50 parts, one of those parts, okay, needs to be the 50% dextrose. So for every 1 in 50 parts, you need to have 50% dextrose. Okay, so that's what that means. So 1 in 50, so 1 divided by 50, multiply it by the 4.5 liters, which is considered 4,500 ml, okay, because it's asking you to give your answer in mLs. Actually, wait. Yeah, it's actually calculate how many ml of 50% dextrose and how many ml of water. So because it's asking you to give your answer in mLs, you need to convert the liters into ml in order to get an ml answer, right? So 1 divided by 50, because that's your 50 part, your dextrose part. Okay, you've established that in order to dilute this, you need 1 part of dextrose out of the entire 50 parts in total. So you need 1 part of 50% dextrose, and you multiply it by the 4,500 ml that you need to make the solution. So that tells you that you get an answer of 90, which states out of the 4,500 ml, 90 of that of the ml in that 4,500 needs to be 50% dextrose in order for your formula to be 1%. Okay, that's what this whole thing means. All right. Okay, and then you have the water. So first you're being asked how many ml of the dextrose do you need? So you establish that you need 90 ml of the 50% dextrose, right? Because that's your equation for up top. And then you need to determine how many ml you need of water to get this 1% strength. So you do your 49, because 49 is right here, how many parts of water that you need. Okay, so 49 parts of water divided by your 50 total parts, and then you multiply that by 4,500 ml to get a total of 4,410 ml. So you need 4,410 ml of water and 90 ml of dextrose in order to get a 1% strength of this solution. And if you add the 4,410 plus the 90, you should get a total of 4,500 ml, which shows that you did your problem correct for that matter. Okay. Now let's do number 2. How many ml of a 50% solution Sorry, that's the Roomba. Okay, how many ml of a 50% solution and how many ml of a 5% solution is needed to prepare 4 liters of a 10% solution? So you know you have a 50% solution, right? So that goes up there. And how many ml of a 5% solution, which goes down there, if you need to prepare a 10% solution. Okay? So you got your 50, you got your 5, and you need to make a 10. So 50 minus 10 is 40. 5 minus 10 is 5. Okay? Because there's no negatives. So in total, you have 45 parts. So then you add these parts together. Okay? 45 parts in this formula. Okay? And out of those 45 parts, 5 of those parts, 5 out of the 45 needs to be 50% solution. So 5 out of 45, multiply it by 4,000 ml because 4 liters is 4,000 ml. Okay? 5 out of the 45 times the 4,000 ml tells you that you need 444 ml of 50% solution. Okay, it goes in a straight line. Okay? Then you need to figure out how much 5% solution you need for the rest of the problem. So then you get your 40 parts out of your 45 parts and you multiply it by 4,000 because that's how much 4 liters is. And you get a total of 3556 of 5% solution. So you need 3556 of 5% solution and 444 ml of 50% solution. And you need to mix these two together in order to get a 10% solution at the end of the day. And you can double check your work. If 3556 plus 444 equal 4,000, you're off to a good start. Or it basically shows that you're correct. Okay, so number 3, how many ml of a 15% solution of sodium chloride and ml of water should be used to prepare a 1 liter of a 0.9% solution of sodium chloride? Okay, so you know that your first sodium chloride, the how many ml of a 15% solution of sodium chloride, so this is sodium chloride, 15%. And ml of water, which is 0. And what you're trying to make is a 9% solution of sodium chloride, okay? How much of this and this should be used to prepare a 9% solution of sodium chloride, okay? Again, you do your math. 15 minus 0.9 is 14.1. 0 minus 0.9 is 0.9 because there's no negatives, right? So 0.9 and 14.1 is a total of 15 parts. Okay. So now, your 0.9 over 15, and you multiply that by 1,000. Why are we multiplying that by 1,000? Because we're asked to prepare 1 liter. 1 liter is 1,000 ml. So 0.9 divided by 15 multiplied by 1,000 gives you 60 ml. This 60 ml, because it falls in the same line, right, of your tic-tac-toe, is 60 ml of 15% solution. Okay, then you get your 14.1 divided by your 15 ml, or parts, sorry. 14.1 divided by your 15, and then you multiply it by your 1,000 ml to get 940 ml of water, or H2O. And that's how you get your answer. Okay. I have just a few more because I think they're all beginning to sound and look the same. I did just a couple. All right. Number 4 is how many ml of each of a okay, of a 20% stock solution and a 30% stock solution will a technician need to make 28% stock solution with 500 ml total? Okay, you need to make 500 ml of a 28% solution, and you have a 20 and a 30%. Okay, so you do your tic-tac-toe box, you put your 30 up top and your 20 on the bottom because those are the two numbers you're working with. Then you put your 28% in the middle because that's what you want to end up with. Okay? So your 30 minus your 28 is 2 parts. And your 20 minus your 28 is 8 parts because there's no negatives. So 8 and 2 is a total of 10 parts that you're working with. Okay? So your 8 out of 10 parts, 8 divided by 10, multiplied by the 500 ml that you need, equals 400 ml of the 30% solution. So you will need 400 ml of this solution in the bottle, okay, and 100 ml of this solution in the bottle to get a total of 500 ml in the bottle that is worth its strength is 28%. Okay, so you do the same thing. 2 divided by 10, which is your 10 parts. 2 divided by your 10 parts, multiply it by what you need to make, and you get how many ml you need of that strength. Okay. All right, and let's do these two. A technician is to prepare 2.5 liters, this is number 7, of a 1 in 20 part solution from a 30% solution and water. How many ml of the 30% solution and water is needed? Okay, so you know that you need to make 2.5 liters of a 1 in 20 part solution. Okay, and you have a 30 and a water. So your 30 and your water is 0. Okay. And again, whenever we have 1 in 20 parts, right? That means 1 divided by 20 multiplied by 100 so you can make a percent. Okay, so 1 divided by 20 is 0.05. And you multiply it by 100 to get a percentage of 5. Okay. So 30 minus 5 is 25. 0 minus 5 is 5, right? Because we don't do negatives. And then we need to figure out of the 30%, right? Out of the 30 parts, 5 of those parts need to be 30%. You multiply that by your 2,500 ml, and you get a 416.6 or 417 in this case, right? So you need 417 ml of your 30%. Same thing on the bottom, 25, right? 25 out of your 30 parts because your total parts is 30. 25 out of your 30 parts, multiply it by 2,500 ml, tells you that you need 2083 ml of water. $20.83 and $4.17 should give you your 2,500. All right. Let's move on to number 9. A hospital clinic requests 2 pounds of 2% hydrocortisone ointment. So 2 pounds. You know your 1 pound is technically 453.59 or 454. I kind of did 453 here and I realized that I was short, so I kept going and doing it by the 454. But whatever. Whatever the case is, it's approximately 453.59 or 454. 453, 454. Okay, that's your 2 pounds or your 1 pound. So in order to get 2 pounds, you need to multiply it by 2. 454 times 2 is 908. Okay, or so, yeah. 908. Okay, so how many grams of 5% hydrocortisone, so 5% hydrocortisone ointment, will be diluted with petroleum, which is 0% because it's neutral. Okay, it'll tell you it's 0% neutral. So you have a 5 and a 0. You need to make a 2%. You put that in the middle. And then you subtract. 0 minus 2 is 2 because no negatives. 5 minus 2 is 3. Okay. Total parts, 5. All right. Your 2 out of your 5 parts, 2 divided by 5, multiply it by your 2 pounds, which is 906. 906. In this case, I put 906. It's supposed to be like 908 now. I did 906 because I was doing 453. You get a 362.4, rounded up to 363 of the 5. Okay? Of the 5%. Then you do your bottom, 3 out of 5, 3 parts out of your 5. You divide that, multiply it by your 908 to get your 544.8 or 545. And then your total parts would be equal to your 2 pounds, which should be 908. So 363 and 545 should be your 908. And that's how you can check to make sure that you did it right. Okay, let me just double check that. Yeah. This should equal your 908, your 2 pounds in total. Okie dokie. Let's see where else. I think there was, all right, there was a tricky one here. That we'll do these 2, and I think we'll do three of them. There's 3 more we should do. Okay. So number 12 states, how many ml of a 16% stock solution are needed to compound 400 ml of a 1 in 2,500 part solution? Okay. So here we're only given one stock solution. Okay. So our bottom will be 0 because we're not really adding anything. Okay. But it says that you want to make 400 ml of 1 in 2,500 parts. Again, 1 in 2,500 parts means 1 divided by 2,500, and then you multiply it by 100 in order to get your 0.04%. Okay? So the way you set this up is you do your 16% up top, then you do your 0 on the bottom because you're really not using another, what's it called? You don't have another percentage to work with, okay? And you put your 0.04 in the middle because that's ultimately what you want to end up with. And you crisscross and you subtract, Your 0 minus your 0.04 will equal your 0.04. And then your 16 minus your 0.04 will equal 15.96 to get a total part of 16 parts, okay? Total, you have 16 parts. Then you go ahead and you do your equations or your calculations. 0.04 divided by your total of 16 parts, multiply it by the 400 ml that you need, will give you 1 ml. So you need 1 ml of the 16% stock solution in order to have or get a 0.04 strength. Okay? And that's technically your answer, that you need 1 ml. And basically you would need 399 ml of something else, or the neutral, to complete your 400. But it's only saying that you need to provide the patient or you need to provide the compound that you're going to work on, okay? You need to make it 0.04%, and in order to get that is by taking 1 ml out of this stock solution and making it that. Okay, that's the best way I think I could explain that. All right, and let's do number 13. Okay, it says calculate how many ml of a 1 in 2 solution, okay, 1 in 2 part solution, and ml of water are needed to prepare 50 ml of a 15% solution. Again, the 1 in 2 solution means 1 divided by 2 multiplied by 100, which gives you 50%, okay? So you need to work with basically a 50% solution and with water in order to end up with a 15% solution, okay? That's what this whole thing means. So 50 minus 15 is 35. 0 minus 15 is 15 because there's no negatives. Okay? Then you get your 50% solution. 15 parts out of your 50, right? This is your total parts. 15 and 35 is total parts of 50. So 15 out of your 50 parts, multiply it by 50 ml because that's what you need, right? And it tells you to give 15 ml of the 1 and 2 solution, of the 50% solution, okay? So you need 50 ml of that, okay? And then you need, by doing the same thing, 35 over 50, multiplying it by 50, shows that you need 35 ml of water. So in order to get 15% solution, a 15% solution for 50 mLs, you need 15 of those mLs to be the 50% solution, or the 1 and 2 solution, and 35 of those mLs need to be water. Okay. Okay. Sorry. All right, and then we have one more to do for this video, and then we'll call it a day because they're all pretty much the same situation. Okay, the same example repeated over and over again. Okay, so number 23 states you have 2 very dilute stock solutions that are available to prepare 60 ml of a 1/1000 weight volume solution. Okay, and the 2 stock solutions are 1 in 200 weight volume and 1 in 2000 weight volume. How many of each are required? Okay, so again, anytime you see this kind of thing with the semicolon, you just divide by the top and the bottom and multiply by 100 so you can make your percentage. So you can create a percentage, because percentages is what we like to work with. We don't like to work with numbers like this. Okay, so first off, you need to create 60 ml of a 1/1000. So a 1/1000 is your 1 divided by 1,000 multiplied by 100 to get a 0.1%. Right? So that's what your ultimate goal is in your tic-tac-toe. So you create your tic-tac-toe, you put your 0.1% in the middle because that's what you really, really are looking to do. Okay, then you do the same thing with all the other 2. 1 divided by 200 multiplied by 100 to get your 0.5. So you stick that up there. And 1 in 2000 divided by 100, which gives you 0.05. And you stick that down there, right? Because this is your higher and this is your lower. And you do your subtraction. 0.5 minus 0.1 is 0.4. 0.05 minus 0.1 equals 0.05. Right? I think so. Hold on, it looks a little weird right now. Minus 0.05 is 0.05. Okay, yeah. yeah, because it's 1 minus 5. Okay. 1 minus half of it. Okay. All right. Sorry, it looked a little strange really quick. I was just making sure I did it right. Okay, so then your total parts is 0.05 plus 0.4, which gives you a 0.45 of parts. Okay. All right. So now you get your 0.05 divided by your total parts, which is 0.45, and you multiply it by your 60 that you need in order to get a 6.67 or 7 ml of the 1 in 200, because the 1 in 200 is the 0.5. So you need 7 ml of the 1 in 200, okay, because that's where you stuck your big one. All right, and then you need to do your 0.4 over your 0.45, multiply that by 60, and you get 53 ml of your 1 in 2000 part drug. And that's how you do that one. Pretty much you do all of them the same way. You just need to know what it's asking for. When you don't have a number that, I guess, complete, like if it does not give you a number, you're working with a 0 at the bottom in most cases. But other than that, this is what the general idea of allegations is. I hope that made you understand a thing or two. If you have questions, leave them in the comment so we can answer it just once. Thank you.